Hello and welcome to Lesson 4. This lesson will introduce the idea of a machine learning pipeline. A pipeline will take multiple steps in a machine learning process and combine it into a single object, which makes it easier to both develop and use, as well as save and reuse later. So by the end of this lesson, you should be able to articulate the concepts behind a machine learning pipeline. You should be able to explain why is it beneficial to use a machine learning pipeline. And you should also be able to create and deploy machine learning pipelines by using the scikit-learn library. One of the main things that I want to emphasize here is that when you put data analytics processes into production, it's generally going to be done as a pipeline. And so if you can start this pipelining in the deployment and development process on your laptop or on your desktop, it'll make it easier to move into, say, the cloud, where it's going to run on a cloud computing system on very large data. And that's because you've already sort of encapsulated the different pieces and put them together in a way that will scale more naturally. The reading for this particular lesson is the notebook, and there's going to be 3 specific concepts that we're going to look at. The first is a voting classifier. This is a generalized version of ensemble learning. We're then going to spend most of the time talking about pipelines and how to build them and why you would want to use them. And lastly, we're going to look at multi-output regression again. We saw that in a previous notebook, but I want to make sure that you actually are familiar with this. It's something that we often don't think about. We're often saying, well, we're just going to predict this one value, but the ability to predict multiple values is actually a really powerful thing. We don't actually talk about it here, but you can do the same thing for classification, where you predict multiple labels. So again, we're going to look at classification for the iris dataset using the voting classifier. We're then going to move on to pipelines. We're going to specifically build a pipeline for regression on the AutoMPG data. And then lastly, we will look at multi-output regression. So first, voting classification. We've looked at lots of ways to do classification, everything from logistic regression to support vector classification, decision trees, random forests, gradient boosted trees. What about taking these different algorithms and combining them somehow? Well, this is the third form of ensemble learning, where we simply take the predictions from different algorithms and we use a voting process to combine the results. And the voting process can be simple, where you simply say majority rules, or it can be more complex, where you want to use probabilities or weights that somehow favor better performing algorithms. The idea is that if we have different algorithms that are working together, they may be able to complement each other naturally so that the final result is a better, more powerful classifier. We do this by using the voting classifier. And it has one hyperparameter that is the estimator, right? And this is typically a list of the algorithms that you want to use, the actual estimators that implement those algorithms. And it typically contains tuples that map a name, so the name that you're going to call that estimator, with the actual scikit-learn estimator. Another thing that we have to look at for hyperparameters is the actual type of voting. One is the hard voting, which is just majority voting, and the soft is where you're going to vote using some classification probabilities. And then lastly, we can use the weights hyperparameter to alter those 2 voting techniques so that you're doing either weighted majority or weighted summed probabilities. So let's jump straight in and look at the application of this to the iris dataset. We're going to hold 25% of our data out for testing. We're going to build 3 estimators, a k-nearest neighbors, a logistic regression, and a random forest. Notice that we're simply accepting default hyperparameters except for the number of neighbors, which we specify to be 1. We say we're going to use soft voting, which is summing the probabilities. We apply it, and we see how well we did, and right off the bat, we're doing quite well. We have 97% accuracy in this particular task. You can try changing those parameters and seeing how things improve or perhaps get worse. Next, we're going to look at the decision surface. We're going to see for KNN, what's the decision surface? You can see it's all over the map, right? It's really crazy. It's carving out these things. We can look at logistic regression, very different again. Has some accuracies and some problems. And then we can look at random forest. And then we can see how do these get combined together. And you see the voting classifier has the ability to generate very complex decision surfaces. And that's really an interesting thing. In this simply 2-dimensional surface is already complex. Imagine how complex it could become in multi-dimensions. All right, we can now apply it to the real-world adult data set. We can look at the data. We can look at the model itself, what we're going to do. In this case, we're going to hold 40% out. Same 3 classifiers. Again, using default parameters, except now we're saying 5 neighbors. We apply our model to the data, we see our results, and it's doing quite well. Again, we simply took the basic default parameters and are already doing this well. You could imagine throwing in a few more algorithms, maybe tuning the hyperparameters, and this performance might go up significantly. So hopefully I've shown how the voting classifier is an important algorithm and how you can get useful information out of that. The next thing we want to look at is machine learning pipelines. The idea of introducing voting classifier first was you build a pipeline in much the same way. In fact, the voting classifier can be thought of as a pipeline where you're sort of doing things in parallel. Typically, pipelines are more sequential. So we're going to demonstrate this by using the regression problem for fuel prediction. We're going to make our data, but we're not going to do everything all at once. First, we're going to notice that the horsepower feature actually has several unknown values. And thus, we want to both create our data and actually scale, process before machine learning. So what we're going to do is make a copy of our data. So the first thing we have to do is we have to replace the missing values. We do this with an imputer. And then we want to actually transform the data for our result. So how do we do that? We apply an imputer, and we see that once we've done that, there is no missing data anymore. Second thing we might want to do is scale the data. We haven't done this in this particular application before, but often it can improve performance. So we've imputed, now we want to scale the data. We're going to fit it so that it all has that normalized relationship where it has a zero mean and a unit standard deviation. So once we've done that, we can actually go through the whole process of applying a regressor, getting our results out, seeing we're not doing too bad. But now let's combine everything together into a separate pipeline process. So we're going to create our pipeline. We're going to add our random forest regressor. Technically, we need two pipelines though, because we first have to impute and scale the data before we can apply that regressor. So we're going to go ahead and do that, create both of our pipelines. We do this in this particular cell. We create our first pipeline off of our imputer and our scaler. We then create our second pipeline off of our regressor. We both run both pipelines, we get our results out, and they agree with the previous results. So this showed you how to build pipelines. In this case, we built two. We ran them sequentially. We could build more complex pipelines, and these are things that we'll be doing as we go forward in the class because we'll be using pipelines more and more, and that should hopefully give you an introduction to those. The last thing is regression multi-output. Again, we've seen this before. The idea is we can take features and put them into our dependent feature list. We, of course, have to drop it from our independent features. We can train our model, make predictions, and make measurements. And notice this is doing quite well, this particular application. So with that, I'm going to go ahead and stop. Hopefully you've gotten a real appreciation for the power of ensemble learning in this particular module. You've seen random forest, you've seen bagging, you've seen boosting and gradient boosted trees, you've now seen voting classifier and pipelines. It's a lot of powerful techniques that were introduced, which will improve your ability to perform machine learning. If you have any questions, let us know, and good luck.